Hello and welcome to today's lesson. We're going to be talking about experimental probability. And so there's a difference between theoretical and experimental probability. So it's important that you understand the difference between those two, and that when you are doing these problems mixed in with other problems, that you realize that it's asking for the experimental probability and not the theoretical probability. Because often you get two different answers and they're going to give you both answers. So just make sure you pay close attention to which probability they are asking for, and that way you can get the answer right. So as I'm going through those notes, please make sure that you copy them down so that you have them to reference when you are studying and trying these problems on your own. And then if I ever go too fast, just pause the video and rewind so that you can get caught back up. And you can even pause at the beginning of a question. You calculate the probability, showing all of your work, and then go back through and watch the video to see if we do things the same way and if we get the same answer. And if we do, that's great. You know that you're on track. And if not, that just gives you an excellent way to know exactly what areas you need to study in. So I'm so glad that you are joining us today, and let's go ahead and take some notes.
Experimental probability is the result of the experiment or simulation after a large number of times. So you're using the actual data from an experiment. Whereas theoretical probability is what is expected to happen based on the possible outcomes. So this is like you roll a heads and a tails. What's the chances of a heads? 1 out of 2 times. Whereas experimental, you would actually flip the coin, say 100 times, and record your data and count up the number of times heads was flipped and then put that over 100, the total number of times. So that's the difference between experimental and theoretical. And experimental is what we are going to be looking at. Which that experiment is here, only they did it 20 times and they actually went and recorded it. So here the probability of heads being flipped would be 13 out of 20. Tails would be 7 out of 20. Because you're putting the number of times the event occurred over the number of trials when you're finding experimental probability. So that's why it's important to realize when you're being asked for the experimental probability and when you're being asked for the theoretical probability. In this first question, we're looking at a spinner, and there's 10 different colors labeled 1 through 10. And Eden spins the spinner 12 times and records the different results in this chart. And it wants to know, what is the experimental probability of spinning a 5? So I'm looking for how many times a 5 was spun. So nothing in this column of results, no 5s in this column, no 5s in this column. So that means that 5 was spun 0 times out of 12 spins. 0 over 12 just reduces to 0. So the experimental probability of spinning a 5 in this question is 0, which is C. Devontae placed the cards shown above in a bag. So these cards here. He drew one card at a time from the bag. After each draw, the card was replaced. That means he put it back in the bag. The results of 20 draws are recorded in the table below. What is the experimental probability of drawing a king? So I need to go through and look for how many times a king was drawn. So in the first column, there's 1. In the second column, there's 2. In the third column, there's 1. And in the fourth column, there's 1. So that's a total of 5 times that a king was drawn. So that's the top, my numerator of my probability. And that was out of 20. And so the experimental probability is 5 over 20, but I can simplify that. 5 over 20 simplifies to 1 over 4, and you can use your calculator to help you with that if you have a scientific one, or you can just divide the top and the bottom both by 5, and so that's going to make A my final answer. Jamie, Lisa, and Drew each have their name written on a piece of paper in a bowl. One name is drawn at a time from the bowl. After each draw, the name is replaced. It's put back. The results of 15 draws are in the table below. What is the experimental probability of drawing Drew's name? So once again, I'm going to look for Drew in the result columns. So here, there's 2 Drews, 1 Drew in the middle, and 1 Drew in the last column. So that's a total of 4 times that Drew had his name drawn out of 15. I can't reduce that, so my experimental probability of drawing Drew's name is 4 over 15, which makes B my final answer. This question says Jason owes an electronics store. He observed that on a certain day of the 25 customers who visited this store, 3 customers purchased a data storage device. What is the experimental probability that the next customer will purchase a data storage device? Well, there were 3 customers that purchased that device, so that means it happened 3 times out of a total of 25 customers. So the experimental probability is 3 over 25, and I can't reduce that, but if I look at my answers, they're all in decimal form. So that means I'm going to need to divide 3 divided by 25 on my calculator, or by longhand if you prefer, but when I type, you always type numerator then denominator. 3 divided by 25 is 0.12 or 12 hundredths. And so that's going to make my final answer B. This question says Jake rolls a 6-sided die numbered 1 to 6. So that means on every side there's either 1, 2, 3, 4, 5, or 6 with all of them. And he rolls that 5 times. On 2 of those attempts, he rolls a 3. So what is the experimental probability that the number on the die will be 12 in the next attempt? Well, there's no 12 on this die, so he can never roll a 12. And so that means that he has 0 outcomes where he rolled a 12 on his 5 rolls out of 5, and 0 over 5 reduces to 0. So since 12 doesn't exist on his die, the probability of that occurring is 0%, which is letter B. Brian rolls an 8-sided die cube numbered 1 through 8. So this one now has 8 sides, and he rolls it 6 times. What is the experimental probability that the number cube lands on a single-digit number? So he's rolling this, and he has the numbers 1, 2, 3, 4, 5, 6, 7, 8. Those are all single numbers. So no matter what he rolls when he's doing his experiment, he's always going to roll a single number. And so he rolls a single number all 6 times out of 6. 6 over 6 reduces to 1. So that means the probability here is D, 1. This question says Loretta is giving out pieces of candy to her 25 friends. Out of them, 15 friends got a piece of grape candy. What is the experimental probability that the next candy given will be a piece of grape candy? So getting a piece of grape candy happened 15 times. So to 15 friends, so that's my numerator. And she gave out a total of 25. So that's my denominator. So I'm looking at my answer here, and it wants the answer as a percent. So I'm going to take 15 divided by 25, and that's going to give me 0.6. And then I need to convert that to a percent by multiplying that times 100 or moving the decimal twice. Either way, that's going to give you 60. So 60% is my final answer, which is choice C. This question says, Naomi surveyed some students to determine their favorite subject. The experimental probability of a student choosing math as their favorite subject is 4 over 7. If 16 of the students choose math as their favorite subject, what is the likely number of students surveyed? So here, to solve this, we're going to need to set up a proportion. So we have the probability of 4 over 7. And we know 4 is the number of students that chose math, and 7 is the total. So I went ahead and wrote that on the side here so I can keep everything straight. So I'm going to set that equal, and it says if 16 of the students chose math as their favorite subject. So since they chose math, that's going to go up here with the 4. What is the number of students surveyed? So I'm looking for the total numbers surveyed, which means my x is going to go in the denominator of my proportion. So now I just cross multiply and divide to solve. 4 times x is 4x, and 7 times 16 is 112. So I have 112 equal to 4x, and then I divide both sides by 4. These 4's cancel, and I'm left with x equals 28. So there was 28 students surveyed, and so that makes my final answer A. The experimental probability of pulling an orange marble from a bag is 5/9. The marbles are replaced after each pull. So what is the most likely number of times an orange marble is pulled if there are 450 pulls? So these problems are working it backwards than the first problems that we did. And once again, we're going to use a proportion. So we're going to take the probability of 5/9. And once again, we know that 5 is the number of times they saw an orange marble, and we know that 9 is the total. So I wrote that off to the side so I can keep that straight. And so I'm going to put my equal sign here, and I have to write the other side of my proportion. So the problem also tells us that there was a total of 450 pulls. So that means that 450 is going to go in the denominator with the other total. And it wants to know how many times an orange marble was pulled. So I'm looking for the number of times orange was pulled, so that means my x is going to go in the numerator. Now that I have my my proportion set up, I just need to cross multiply and divide. So 9 times x is 9x, and 5 times 450 is 2,250. Those equal each other, and then my last step is to divide both sides by 9. These 9's cancel, and I'm left with x equals 250. So that means when they conducted this experiment, orange was pulled 250 times out of 450 total times, which makes C my final answer. Thank you for joining us today, and I hope you learned something new.